All right, folks, for our 45th installment here, we're going to look at solving contextual problems using the normal distribution. That sounds interesting. You wouldn't think it was possible, would you? But it is. You'll see. So we're going to talk about developing a solution strategy, which is never a bad idea. And then we're going to talk about solving involving, that's hard to say, percentages and areas. So those two things are going to be important for us. Here we go. So if we're going to develop a problem-solving strategy that involves using a normal distribution, so as always, we want to read and understand the problem and clearly identify and label the important values that are given. From there, it's going to be real important for us to make a sketch of the normal curve. And I cheated a little bit and gave myself a bell curve on each one because you know how bad I can draw things. So we're going to sketch a normal curve and we're going to plot the given values in the correct locations, and that'll help us understand what's going on. Then it says understand what the problem is asking in terms of the mean and the standard deviation, areas, and percentages. Because those four things are really all we know about, but they're going to help us a lot. And then we just perform some simple arithmetic, because that's usually all that's required in terms of writing stuff with a pen. So some simple arithmetic in order to answer the question. Let's see what this business is all about here. So example 1, it says the heights of spruce trees in Terra Nova National Park. Okay, so they're all different heights, I would imagine. It says they're normally distributed with a mean of 8 feet. So an average spruce tree would be about 8 feet tall. Okay, I believe it. And they have a standard deviation of 2.5 feet. Okay, so on average, one of those spruce trees varies away from the mean by about 2.5 feet. Okay, so what percentage of the spruce trees are between 3 feet and 13 feet tall? Okay, before I answer any questions, I'm going to use the sketch that we have over here. So we read the problem, I think we understand it, and so the two quantities that they tell us about are the mean, which they say is 8 feet, and they tell us that the standard deviation is 2.5. So we got that. Now we'll do our sketch. And for the sketch that we have here, mean goes right in the middle, so this is 8. Now, within 1 standard deviation of the mean, within 2 standard deviations of the mean, and then within 3 standard deviations of the mean, we've got certain percentages of our data. Okay, so within 1 standard deviation of the mean, I'm allowed to go 2.5 feet, I guess, above 8, which would take me to 10.5, and 2.5 below would take us to 5.5, wouldn't it? And then another 2.5, so 2 standard deviations above would be 13, sorry. And 2 standard deviations below would take us to 3. And then 3 standard deviations above would be at 15.5. That's a tall spruce tree. And then 3 standard deviations below would just be at 0.5, so just a little sapling or something. Okay. What percentage of the spruce trees, it says, what percentage of the spruce trees are between 3 and 13 feet tall? Well, let's see. Over here on our bell curve, on our normal distribution, we have 3 and 13, and that's -2 standard deviations all the way up to +2 standard deviations. And we should know that within 2 standard deviations of the mean, we have what percentage of our data? That's right, we have 95% of all the spruce trees. So that's easy. It's just 95%. Sounded really weird and complicated until we drew a picture, huh? Okay, so that's the simple arithmetic. Write down the number. There are about 550,000 spruce trees in the park. That's a lot of trees. How many trees are between 5.5 and 10.5 feet tall? Okay, so let's look at our diagram again. 5.5 feet and 10.5 feet is sort of 1 standard deviation to the left and 1 standard deviation to the right. So within 1 standard deviation either way, we should have 68% of all of the spruce trees. Okay? So if there's 550,000 of them, and we're talking about within 1 standard deviation either way, we got 68% of them. So 68% of 550,000. Well, that doesn't sound too hard. 0.68 times 55, 4 zeros. What's that going to be? Hello, handy dandy calculator. 0.68 times 55, 1, 2, 3, 4. I'm saying 374,000 spruce trees. Okay, so we got 374,000 spruce trees, roughly, fall in that perfect range between 5.5 and 10.5 feet tall. Maybe those are Christmas tree size, I don't know. Okay, next one. A manufacturer of microwave ovens determines that an average unit has a lifespan of 4.5 years. As soon as they say average, I'm thinking right away, I know that my mean is 4.5. The lifespans are normally distributed, that's good, with a standard deviation of 1 year. Okay, so my sigma is 1. How long should the warranty be on each unit? Be if the manufacturer only wants to service 2.5% of its product? That's tricky. Let's see. So right here down the middle, I got 4.5 years is the average lifespan of one of these things. And then every standard deviation is just 1 year in the difference. So this is going to be 3.5 years up to 5.5 years. So we have like 68% of our data. So 68% of our microwaves will last between 3.5 and 5.5 years. And then between 2.5 and 6.5, we're going to get like 95% of them. Okay. Okay, that's all right. And then within 3 standard deviations, well, we get a huge number of them. So we got 1.5 here, we got 7.5 there. Now the percentages are what matters. It says the manufacturer only wants to service 2.5% of its product. So obviously you're going to service the microwaves that die the quickest. So let's see. We want to take off and service just one group over here that's really the smallest group. And that group down there, we have to have 2.5% on this side. And we want 97.5% would be the rest of them to last longer than the period of time that we're going to give a warranty for. Okay, well, let's remember that between 2 standard deviations we have 95%, which means we'd have 2.5% on each side for a total of 5%. So as long as we give our warranty only up as far as 2 standard deviations below the mean, we should be safe. So I'm going to say we're going to warranty for 2.5 years. And let's hope that works. All right, that looks good to me. So remember the 3 steps: read, sketch a diagram, understand, and do the arithmetic. Hope that helps.